Alright, hello, this is going to be Solidworks CSWA practice problem 7.10. And if you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First of all, your units are going to be in MMGS. And then we're going to start our sketch in the top plane. For this problem, don't be afraid when it says that's going to take 45 minutes to complete. It's actually a pretty basic part. I'm not sure why it says 45 minutes. Sometimes there'll be a problem that says it you can complete in like 20 minutes, but it ends up taking like an hour. So don't think too much about it. But we're going to create the bottom base part first. So let's create our vertical center line to prep the mirror. And let's just draw one side. So I'm going to draw a horizontal line, which will go into a diagonal line, into a vertical line, and then to the origin. I'm going to make sure that this endpoint is vertically coincident with the origin, just to make sure. Okay, let's start dimensions. Actually, well, first I'm going to mirror all these. So I'm going to click mirror entities, and let's mirror those 4 lines. Select OK. Now the top, the skinny head is going to be 70 in length. The distance from the top side to this corner right here is going to be 30. And then the total width of the part is going to be 135. And then the total height of this is going to be 52. And then let's add 2 circles. Well, I'll just add 1 circle and then I'll mirror it to the other side. Let's give it a diameter of 8. Let's make sure its center point is distance 25 from the top edge. 25. And then let's make sure that the distance between each of their centers, like this, is going to be 100. And then finally, we'll add some fillets. So I'm going to go to sketch fillets, make it 5 millimeters. And we'll add 4. All corners aside from the top left and top right corners. All R5 fillets. Select OK. And that's it for your base part. So we can go ahead and extrude this. So feature extrude. Extruded upwards by 10. Select OK. Now we're going to extrude the backboard. So I'm going to flip this around. And I'm going to start a sketch on the back side, like this. Okay. So from here, let's create a really big circle, centered from the origin. Let's give this a diameter of 125. Then let's add a line at the top, cutting across like this, a little cap. That line's distance from origin is going to be, what is that? 60. And then we'll close off the contour. Or actually, I'll just use convert entities. Make it a little easier. I'll just convert entities this edge right here. Select OK. And I'll just trim away everything we don't need. So I'm going to trim away this excess at the top cap. The convert entities excess. And everything below the convert entities line. So all of that. And that's it. And then from here, yeah, while I'm here, I'm going to add 2 circles. So I'll use another mirror tool. So I'll just put a circle. Well, actually, no, let's not put the circle yet. Let's get our angled center line, which we will use to constrain the center of the circle. So I'm going to get an angled center line. This angled center line's angle from the horizontal is going to be 50 degrees. And we need a center point arc. And the arc is going to be centered at the origin. I'll just create an arc like this. Let's set this for construction for now. Just to make it pretty, I'm going to make the endpoints horizontally constrained. And let's give this construction arc a I see. So in the drawing, in the front view drawing, it actually says diameter 95, which means this arc's radius should be 47.5. 47.5 for its radius, which is half of 95. Yes, and then from there. And you'll notice that there's an intersection between this angled construction line and then the construction arc line. And this is exactly where the center point will be fixed for the circle, right on that intersection. All I need to do is add a diameter to it, and it'll be fully defined. And for the diameter, it's going to be 12. And then now all I have to do is just mirror this onto the other side. And then that should be it for now. Okay, I'm going to extrude this backboard. And it's extruding the wrong way, so I'm going to flip the direction. And it's going to be extruded a depth of 10. So it should be correct, so select OK. So now, let's extrude the tunnel, and then we'll make the cut, we make the holes later. So I'm going to start a sketch. Yes, I'm going to start a sketch on the front face, like this. And then I'm going to get a center point arc, and I'm going to make the origin my center. And on this, along this line, which is going to be the kind of the front edge of the base part, I'm gonna make coincident this center point arc. And I'm going to give this arc a radius of 30. And then I will close out the contour with a line. But while we're here, we might as well also extrude the other part, which is going to be just like we constrained this circle right here, this hole. We're gonna constrain this circular protrusion as well with an angle, with a construction arc, or actually with an arc and then an angled line. Well, the arc we already have, it's actually right here, so we're gonna use this as the arc, but then we need an angled construction line, so I'll make that right now. This time, instead of being angled 50 with the horizontal, it's going to be angled 75 with the horizontal. So 75 degrees. And then I'll find that intersection right there. And I'm going to make a concentric pair of circles. The first circle is going to have a diameter of 7. And the second circle is going to have a diameter of 18. Oh, seemed that the auto smart dimension didn't catch it, so I'm gonna add a coincident. So there should be coincident. And then from here, I believe you're gonna need, there should be arcs. Yes, there should be we should need some more arcs. So I'm gonna add a 3-point arc that's connecting this circle, and then we're gonna add the tangent relations. So a 3-point arc, let's add it like this. And I'll do the same on the other side. Let's add those tangent relations. Same for the other side. And it never provided dimensions for these two arcs specifically, so we're just going to assume that from the top view, remember the R5 typical, that these arcs are also R5. So we're gonna say, actually, well, I'll set them equal to each other first. So equal. And then I'll just have one of them be R5. R5. And then from there, I'm just going to trim away anything we don't need. So let's get the trim tool up, and I'll trim the bottom half of the circle. I'll trim this part, and then the line inside of this hole here. Oh, and also this. Wait, hold on. Let me undo that. Something weird just happened. So, trim. There you go. Okay. So that's how it should look. I was actually supposed to, yeah, I'll have to extrude this hole separately. I have to extrude everything first and then cut this hole in order to cut it through the backboard. So we'll just go features, then extrude while space, and I'll flip the extrusion, and I'll just extrude it up until the next surface. Or I can just click up to next, same thing. So extrude up to next, and select OK. And then I'm going to make the last hole. And I'll also finish out this hole as well. So let's create another sketch on that same face. And all we need to do is just add a 40 diameter circle. Let's make this 40 diameter. Then I'll close out the contour like so, and trim away the rest. And I guess I'll just use convert entities for this circle I made here. And we'll just do a through cut for both of these. So extrude cut, and through all. Select OK. And that should be your completed part. Let me just make sure I didn't miss anything. Nope, that should be it. Okay, so let's check our answer. Let's go to evaluate, mass properties, and then for your volume, you're going to end up getting 113,890 cubic millimeters for your volume. 113,890 cubic millimeters for your volume, and which should be the correct answer. So I hope you learned something from this video, and I'll see you in the next one.